here's the next video. This is a series of 2 or 3 videos about the same data, and I split it up into 3 or 4 videos just so you know, okay? So this is the Markov Semimartingale X Higgs signal codomain Atlas YY Proton random variables, and that's the subject of this video. Quote from Wiki, octal integral. This is a continuation of the previous video. We started talking about it in the last video, so you want to start with that one first. The octal integral is central to the study of stochastic calculus. The integral fx dx is defined for a semi-martingale X in locally bounded predictable process H. My thoughts continue. The key word is semi-martingale X, the X boson particle missing from the standard model connecting to the Higgs boson signal. Google to see what it means. So I'm going to quote from Wiki, semi-martingale. In probability theory, a real valued process X is called a semi-martingale if it can be decomposed as the sum of a local martingale, an adapted finite variation process. Semi-martingales are good integrators, forming the largest class of processes with respect to which the low integral can be defined. The class of semi-martingales is quite large, including, for example, all continuously differentiable processes, Brownian motion, and boson processes. Submartingales and supermartingales together represent a subset of the semi-martingales. My thoughts continue. There it is, a new formula idea. Real value plus process plus X plus semi-martingale plus decomposed plus sum plus local martingale plus adapted finite variation process plus integrator plus forming plus largest process plus L2O integral. Large semi-martingale process, the Higgs boson signal, minus plus differentiable processes plus Brownian motion again, plus Poisson process plus submartingales plus supermartingales, new Higgs particle with mass to study, plus together equals subset plus semi-martingales. My thoughts continued. I have no idea what that means, so I need to Google the words to figure out how the keywords from the WOW data can be combined with your Higgs boson signal data, 2 photons. Quote Wiki, random variables corresponding to various times or points in the case of random fields may be completely different. The main requirement is that these different random quantities all have the same type. Type refers to the codomain of the function. Although the random values of a stochastic process at different times may be independent random variables, in most commonly considered situations they exhibit complicated statistical correlations. Formula idea. Random variables plus corresponding plus collaboration, Atlas, CMS, CERN, plus various times plus time of experiments from Higgs signal to 2 photons being produced in your results, plus points plus case plus random fields plus Higgs boson field of energy produced plus main requirement, plus different random quantities, masses, plus same type bosons, plus new 5 force particles are all bosons according to this data, plus type plus codomain, Google to find out meaning, plus function, use codomain for your functions for bosons, plus random values, plus stochastic process, plus different times, plus change the timing of your experiments, make it longer, plus independent random variables, you will find the independent particles from the Higgs boson signal, plus common situations, plus exhibit, plus complicated, plus look for the anomaly, plus statistical correlations. My thoughts continued. Woo! I know this is confusing. I'm reading between the lines and adding my input to your data based on the WOW videos data I have embedded in my brain after making over 270 videos. I'm going to Google the keywords to see what I find in them. Codomain. And there's a graph about codomain there, fx to y. Quote Wiki, a function f from x to y, the smaller oval inside y is the image of f, y is the codomain of f. In mathematics, the codomain or target set of a function is the set y into which all the output of the function is constrained to fall. It is the set y in the notation f x to y. The codomain is also sometimes referred to as the range, but that term is ambiguous as it may also refer to the image. The codomain is part of the modern definition of a function f as a triple f x y f, with f a subset of the Cartesian product x times y. The set of all elements of the form fx, where x ranges over the elements of the domain x, is called the image of f. In general, the image of a function is the subset of its codomain, thus it may not coincide with its codomain. Namely, a function that is not surjective has elements y in its codomain for which the equation fx equals y does not have a solution. An older definition of functions that does not include a codomain is also widely used. For example, in set theory, it is desirable to permit the domain of a function to be a proper class x, in which case there is formally no such thing as a triple fxyf. With such a definition, functions do not have a codomain, although some authors still use it informally after introducing a function in the form f to x to y. The standard model in Higgs boson, there's the graph there. My thoughts continued. Keywords: f is x to y. F is fermion, x is particle, Higgs with boson mass, a new particle, to y. Y equals the photon, y, photon plus photon, end result of Higgs boson signal. Timing of Higgs boson experiments atlas, your graph came up 3 times with y in it, looking at the atlas data. Atlas YY Higgs boson particle data, wow, new formula, preliminary data, 2011, 7 TeV, FLDT, 1.08 FB should be 604. So what it says, this should be 604 instead of 1.08. So you want to get it to 604. I don't know why, but you want to in order to look at the Higgs boson particle. My thoughts continued. Formula for atlas to look at in relation to graph results. Observed CLS limit. Atlas preliminary data 2011. S equals 7 TeV and SLDT equals 1.08 FB minus 1. Sorry if I have the wrong letter typed here. I have no idea what that long symbol means on your data. I promise to learn it sometime soon. These thoughts continue in the next 2 segments, which is the next 2 videos. Thank you for watching.